Ladies and gentlemen, this is your captain speaking. We'd like to welcome you on board this Airbus 380 flight from Changi Airport to Kuala Lumpur International Airport.
Before taking off, pilot must create a navigation log from Changi to KLIA. First, we will pass through a NDB station, which is KK. Next is VOR station, VJR, VMK, and the last one is VKL. To set the radio frequency, press Shift and 2. Now we are going to set the ADF to 286 kHz for the KK NDB station. After that, we set the VOR1 to frequency 112.7 MHz for VJR with a standby frequency 116.1 MHz for VKL. Next, set VOR2 to frequency 117.4 MHz for VMK with a standby 109.1 MHz for VMKK. After setting the radio frequency, we must turn on the navigation button.
The flight duration is around 1 hour and we are expecting a very smooth flight today. Once again, we thank you for choosing to fly with us today and we hope you enjoy your flight.
380 Heavy is cleared to Kuala Lumpur Airport as filed.
Airbus 380 cleared to take off. Today, we are going to introduce what is Electronic Flight Instrument System Efis about. What is Efis about? Basically, Efis is a flight deck instrument display system in which the display technology used in electronic rather than electromechanical. It consists of primary flight display (PFD) and navigation display (ND). PFD consists of 6 important basic flight instruments. One of the instruments is heading indicator. This heading indicator displays the heading of the aircraft. Artificial indicator, also known as gyro horizon or artificial horizon, is an instrument used in the aircraft to inform the pilot of the orientation of the aircraft relative to Earth. It indicates pitch and bank or roll of the aircraft. Each line represents 10 degrees. Airspeed indicator, an indicator to tell the pilot how fast the aircraft is going. Altitude indicator, to display the altitude of the aircraft from the sea level. Vertical speed indicator, an instrument used to inform the pilot of his rate of descent or climb. Next, we will introduce the navigation display. The navigation display is an instrument which helps pilot to navigate the aircraft from one place to another place by referring to the direction given by ADF and VOR. For the blue labeling is automatic directional finder (ADF), and here is the ADF indicator. Now we are looking at very high frequency omnidirectional range 1 (VOR1), and this is the indicator of VOR1. Next is very high frequency omnidirectional range 2 (VOR2), and this is the VOR2 indicator. For the yellow labeling, as we can see, is the current heading of the aircraft.
Now the aircraft is doing a climbing with 10 degrees. By looking at the artificial indicator, we can see the aircraft is pitching from 0 to 10 degrees. The airspeed is keep decreasing. As we can see, the altitude of the aircraft increases gradually. vertical speed indicator will also increase. Next, we will be doing a clamping with 20 degrees. After doing clamping, we will be moving on to descending. We will start by descending with 10 degrees. The artificial indicator responds very quickly between 10 to -10 degrees. The descending of the aircraft results in the airspeed to increase and the altitude to decrease drastically. In addition, the vertical speed will also decrease. Now the aircraft is descending with 20 degrees. Turning to left with 10 degrees. Inside the artificial indicator, the symbol of the aircraft is tilting to the left at 10 degrees. Turning to the left with 20 degrees. The turning of the aircraft results in the heading indicator moving towards the west. Turning to the left with 30 degrees. Turning to the right with 10 degrees. Inside the artificial indicator, the symbol of the aircraft is tilting to the right at 10 degrees. Turning to the right with 20 degrees. The turning of the aircraft results in the heading indicator moving towards the east. Turning to the right with 30 degrees.
After taking off, we must turn our aircraft heading to the blue ADF indicator, which is pointing to the NDB station KK. When you find that the ADF indicator start to move from 0 degree to 180 degrees, which means we have passed through the NDB station. Thus, we must change the heading according to the white VOR1 indicator, which is the radian given by VOR station VJR. We can see a small triangle at the VOR1 indicator. This triangle is pointing outward, which means we are flying toward the station. When we have passed through the VOR station, the triangle will pointing downward. Next, we follow the direction provided by the green VOR2 indicator and flying toward the VOR station BMK. Instrument Landing System (ILS). An instrument landing system is a ground-based instrument approach system that provides precision guidance to an aircraft approaching and landing on a runway. ILS Localizer, Glide Slope. Localizer provide the lateral guidance portion of the ILS to guide the aircraft to the center line of the runway. Glide slope provide vertical and elevation guidance to approach aircraft. When the aircraft is flying on the runway, the red dot will be at the center of localizer.
When the aircraft is flying on glide path, the red dot will be at the center of the glide slope.
When the red dot is at the right hand side of the localizer, which means the aircraft is flying on the left of the runway, so we must fly right towards the runway.
When the red dot is below the glide slope, which means the aircraft is too high from the runway, so we must fly lower.
When the red dot is at the left hand side of the localizer, which means the aircraft is flying on the right of the runway, so we must fly left toward the runway.
When the red dot is above the glide slope, which means the aircraft is too low from the runway, so we must fly higher.
Now we are flying toward our last VOR station, which is VKL. Ladies and gentlemen, we are about to begin our final descent to KILA Airport. Passengers, please buckle up. Currently at KILA, the weather is fair and sunny. We have certainly enjoyed having you on board today. We hope to see you again real soon, and thanks again for flying Airbus 380.